This is problem 110 of Neetcode 150. Partition equal subset sum. So we are going to be given an array of positive integers. And you want to see if we are able to basically split that array inside two subgroups whose sum is exactly the same. So for example, here, if we're given an array containing 1, 2, 3, and 4, we know that we can basically group 1 and 4 together, which will sums up to 5. And we can also group 2 and 3 together, which will also sums up to 5. So this is two subsets that are equal to one another. All right, so now if we have basically another number, so we have 5 in addition to this, so we have 1, 2, 3, 4, and 5. Can we actually do two subgroups that are exactly of the same sum? Well, just let's take a look at their sum. Okay, so you have 1 plus 2 is 3, 3 plus 3 it's 6, 6 plus 4 it's 10, and then 10 plus 5 is 15. So you have 15, right, as a sum. Can you with 15 divide two groups that are exactly the same? Can you do 15 divided by 2 and hope to have basically two subgroups? No, because you're gonna have like a 0.5, or you're gonna have some nominals. So that is not possible. So this is one thing that we're gonna have to check. All right. So also notice that if we ever happen to actually figure out, like for example here we can see that 2 and 3 are equal to 5. If we know that the sums is 10 and we just found a sub or like a subsequence that sums up to 5, well, we know that all the other numbers will also sum up to 5. So there will be another subsequence equal to 5, right? Because if we take all these numbers together, they add up to 10. And you take two numbers like by pure hazard and they adds up to 5, well, you know that the other numbers will obviously add up to 5, right? Because I mean, it's just the sum minus that particular parts means that the result, the other numbers are gonna sum up to 5. So this is what we're gonna do. So what we're gonna do, it's basically this logic. So let me just erase this quickly. So imagine we have 1, 2, 3, and 4, just like in the example. What we're going to do is that we're initially going to start with an empty set. So our empty set, well, it's going to contain 0. And what we're going to do is that we're going to go for every single value. So we're going to go check 1, and we're going to add that value 1 inside our basically our set. But before that, we want to add 1 basically to all the other values that are currently inside our set. So right now we have a 0. We're going to add 1 to 0. So we have 1. And we also add 1 to, well, we added the number itself to the subset. So now we're going to go see the second number. It's 2. So we're going to add 2 to all the numbers. So yeah, there will be some repetition, but it's fine. So we're going to add 2 to 0, which is going to result in 2. We're going to add 2 to 1, which is going to result in 3. We're going to add 2 to 1 again, which is going to result in 3. But actually, it is not a big deal at this point. And we're also going to add 2 itself inside inside the set. So it is right now holding is here. And now we're going to go see 3, and we're going to basically add 3 to all the other numbers. So we're going to add 3 to 0. So we're going to have 3. We're going to add 3 to 1. We're going to have 4. We're going to add 3 to 1 again. So we're going to have another 4. And now we're going to add 3 to this 2, and we're going to have 5. And notice that from the moment that we have a 5 here, which is half of the target, right? Because in our example here from Neetcode, we want to basically, well, if you sum up all these, you're gonna have 5, right? So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, right? So you know that if you do basically 10 divided by 2, you're gonna get 5. So from the moment that you find a combination that is equal to 5, like here, you know that you're going to have another subset whose combination will also be equal to 5, right? Because we found that 2 and 3 are going to give us 5. And we know that sum of all of these is basically 10. So if you take 10 and you subtract basically the sum of 2 and 3, well, whatever the combination is in our case, we're gonna have 1 and 4, right? So we're gonna have 1 plus 4. But whatever that thing is, we know that this is gonna be equal to 5, which is basically another substring that is gonna be equal to the first substring that we found. And this is exactly what we want to do, right? We want to split basically all the numbers inside our arrays inside two substrings that can basically sum up to the exact same value. So let's go ahead and code this. This is dynamic programming, quite efficient. So let's go ahead and first, well, we want to create a set. So I'm going to say dp.set. And now inside our set, we initially want to add 0. And I will also create a variable s that will just be the sum of the nums. And I want to check if there is a reminder if I divide sum by 2. So if I say if s divided by 2, I am going to trigger this if there is a reminder. If there is a reminder, it means that s itself is odd, meaning that it is not possible to basically divide this by 2 and have two distinct sum. So if this is true, right, I want to return false right away. And with that being said, we actually need a target, right? So what is our target? Well, it's basically going to be half of the sum, so s divided by 2. Why is it so? Because we know that if our array sums up to 10, well, we want to basically have two subgroups that adds up to 5, right? So this is why our target here is going to be set to 5. And now what I'm going to do is that I will go basically for I in the range of the len of s, and I will also basically say for t in or for n, whatever, in dp. But notice that now I'm gonna add values to this dp, so this dp is gonna change, right? So I'm just gonna create a variable called x, and I will set x is basically equal to dp.copy, right? So because inside of this for loop, we're gonna have some values. We're gonna have like the basically the nums at this index I by itself, and we're also gonna have this number plus all the other current values inside our set. But let's go ahead and do this. And also, there's one thing to notice is that if basically the value inside our dp plus the nums at this index I, so if this is equal to target, so in our example, when we add 3 to 2, we had 5, and our target is 5. So if this is equal to target, well, we want to return true. Otherwise, we're going to be willing to add to the dp. So we're going to say dp.add, and we're going to be willing to add this target plus the nums at this index I, so that particular number. And we're also going to add dp nums at this index I. All right, so this is all we need to do. If we never trigger this particular if statement, it means that there is no combination that adds up to basically half of the total sum of this array. So in this case, we are going to be willing to return false. And let's go ahead and submit this. We have an error. So, oh yeah, sure. I said the len of s, but s is actually the sum. What I meant is the len of nums, right? So we want to go through every single number in nums. So let's test this again. We have another error. So I said for t in dp, yes, because that was for an example purposes. But we want to go for t in x. X is basically the copy of dt. Right? We want to keep a copy of the initial dt because we know that basically for each iteration, our dp is going to change. So we can't just either iterate through a set that is going to change for sure. So this is why we want to go through every single values inside x, which is the copy itself. All right, so this is the solution. See, it works quite efficiently. Notice that in terms of time complexity, well, we're going to go basically for every single numbers, right? So if n is the len of nums, we're going to go for n, basically. We're gonna do that times basically the target, right? So we're gonna have a time complexity big O of n times the target. Notice that we are also storing basically that variable target. So big of target is going to be the space complexity inside our set, and target is basically all the possible combinations or sum that we can do um, from our number. So when I refer to target, is basically uh, all these at this instance, right? So the zero, the one, the two, the three, the four, the five. So this is what I mean by target. And basically, we're going to go for every single values inside. So let's say this is our array nums, and it has a length of n. So we're going to do n times basically this target every time. So we're going to have a time complexity of big of n times target. And the space complexity, well, it's only this that we're storing, so it's going to be just big of target. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.